How does JavaScript actually work? Imagine getting this question during an interview. Or how about this? Explain the difference between asynchronous and synchronous in JavaScript. Or maybe they ask you to explain the statement, JavaScript is a single-threaded language that can be non-blocking. Oh boy, in this video, we're going to help you answer those questions. This is a video you may need to visit a few times as you progress to really get it. So don't feel discouraged if you don't feel 100% confident. Just keep watching it and you'll get it. Now, we don't need to know how JavaScript works internally to write a program, but it is important to learn. I see a lot of people who have been developers for years and not know this. It's like being a pilot and not knowing how an airplane can fly. Okay, that's a little bit dramatic there, but you get my point. So let's start. First, what is a program? Well, a program has to do some simple things. It has to allocate memory, otherwise we wouldn't be able to have variables or even have a file on our computer. It also has to parse and execute scripts, which means read and run commands. Okay, now we also know that from our previous discussion, there's the JavaScript engine that each browser implements. In Chrome, it's the V8. And the V8 engine reads the JavaScript that we write and changes into machine executable instructions for the browser. Now, the engine consists of two parts, a memory heap and a call stack. Now, the memory heap, this is where the memory allocation happens. And don't worry, we're going to talk about this. And then the call stack, this is where your code is read and executed. It tells you where you are in the program. So let's simplify this and show you what I mean. I have Sublime Text over here, and for us to allocate memory in the memory heap, well, it's as simple as doing const a equals to 1. We've just allocated memory. Now, when we assign this, the JavaScript engine is going to remember that, oh yeah, a has a value of 1. We've just used up the memory heap. And I can keep going on and on like this, right? I can keep copying and pasting and changing these variables to B and C, and I can change the values to 100, and maybe here will be 10. Cool. Now, what's an issue that we see with this? There's something called a memory leak that you're going to hear as you become a developer. And what we've done here is we've created all these variables, these global variables that are in the memory heap. But you see this box, right? And with all memory, we have a limited amount that we can actually have. So by increasing the number of variables that we have, imagine if I had just this page full of variables, and instead of just numbers, they're like very, very big arrays. Well, memory leaks happen when you have unused memory, such as, let's say we're not using the variable a, but it's still there. Well, by having unused memory just laying around, it fills up this memory heap. And that's why you might hear why global variables are bad. Global variables are bad because if we don't forget to clean up after ourselves, we fill up this memory heap, and eventually the browser will not be able to work. All right, so that's memory. Let's talk about the call stack. What is that? Well, again, with a call stack, we can have something like this. Console log, we'll go 1, console log 2, and then finally console log 3. If I run this code in my browser terminal, well, I get 1, 2, 3. So the call stack, if you remember, that's what reads and executes our scripts. So what the call stack does, it reads the first line, console.log, it gets put in this call stack. So the JavaScript engine says, ooh, console.log has been added. Let's pop it onto this call stack. And then it runs it and creates one. Then it says, okay, I'm removing the first console log because I just finished running it. I'm going to place the second console log into my call stack, adds it on here, and says, yep, execute 2. And then it removes that, it pops it, and then gets console log 3, and logs console log 3, and then finally removes it. But let's have a bit more of a complex example here to demonstrate this point. Imagine I have something like this. I have a function, const1, and inside this function we have another function, const2, and for now it's not really going to do much. It's going to console.log 4. And then in here, we'll just say we run the to function. So if I copy and paste this and place it into our console, and I run 1, I get 4. And ignore this error here, it's just related to my app in the browser. But you see that we get 4. So what happened here according to the call stack? Well, if we have the call stack here, we first ran the 1 function. So on top of the call stack, the 1 function gets run. And as we enter into this call stack, we see that we run another function, 2. So 2 goes on top of the call stack. And now we run the to function, which is console.log. So we have console.log 4 that's run inside of the to function. So now that we've read this, the call stack is going to say, okay, there's nothing else inside of this. I'm going to run console.log 4. So it's going to print out number 4 here. It's going to remove that from the call stack and then remove the 2 and then remove the 1 because it's just been called. And the call stack is now empty. All right, awesome. Now let's revisit the statement from the beginning of the video. JavaScript is a single-threaded language that can be non-blocking. Single-threaded means that it has only one call stack and one call stack only. It can only do one thing at a time. And as you saw, call stack is first in, last out. So whatever's at the top of the call stack gets run first, then below that, below that, below that, until the call stack is empty. Now, other languages can have multiple call stacks, and these are called multi-threaded. You can also see how that might be beneficial to have multiple call stacks so that we don't keep waiting around for stuff. Why was JavaScript designed to be single-threaded? Well, running code on a single thread can be quite easy since you don't have to deal with complicated scenarios that arise in multi-threaded environment. You just have one thing to worry about. And when I say issues with multi-threaded environment, you can have such thing as deadlocks. Now, guess what? You just learned what synchronous programming means. Synchronous programming simply means line 1 gets executed, then line 2 gets executed, and then line 3 gets executed. The latter can start before the first finishes. So this console log 2 doesn't start until console log finishes. And console log 3 doesn't start until these above 2 finish because, well, we've looked at the call stack because of the call stack. Now, you may have heard of the site Stack Overflow. If you're a developer, you use it on a daily. And have you ever wondered what Stack Overflow means? Well, Stack Overflow is this, when a stack is overflowing. Kind of like we talked about memory leaks and how the memory heap of a JavaScript engine can overflow. Well, with Stack Overflow, this happens when the call stack just gets bigger and bigger and bigger until it just doesn't have enough space anymore. How can we do that? Can we recreate a Stack Overflow? Yeah, I can show you quickly that to create a Stack Overflow, all you have to do is function, foo, like we have in here, and this function will just have foo. And we're just going to run our foo function. All right, that looks confusing. What is happening here? This is something called recursion. And recursion means a function that calls itself. So if you look at what this function does, we run foo and foo gets executed. What foo does is, well, we run foo again. So it just keeps looping over and over and over, having a recursion, but there's no end in sight, right? We keep adding foo to the call stack. We keep adding it over and 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 over. And we have a stack overflow. So if you want to have fun, go into your browser, go into your console, and run something like this and see what happens. You're going to get a stack overflow. All right, so hopefully this now makes sense. The JavaScript engine, which is the V8 engine in Chrome, has a memory heap and a call stack. Now, JavaScript is single-threaded. Only one statement is executed at a time. But there is a problem now, isn't it? What if line 2 was a big task we needed to do? Maybe loop through an array that had millions of items. What would happen there? Well, we would have this console log execute, then the second line that is a massive job will just work there. And console log 3 will take a really long time to get logged. And in our small example, that doesn't mean much, but if you had this on a website, well, the user wouldn't be able to do anything. The website would pretty much freeze until that task is done and the user just waits there. That's not very good, is it? Well, with synchronous task, if we have one function that takes up a lot of time, it's going to hold up the line. Imagine a buffet restaurant, right? If all the people want to eat, but Bobby says, hold on guys, I have to keep eating and putting bacon on my plate, well, everybody has to wait in line. So it sounds like we need something non-blocking. Remember our first statement that we made in this video. JavaScript is a single-threaded language that can be non-blocking. Ideally, we don't wait around for things that take time. So how do we do this? Well, asynchronous to the rescue. Think of asynchronous like a behavior. Synchronous execution is great because it's predictable. We know what happens first, then what happens next, what happens third. But it can get slow. So when we have to do things like image processing or making requests over the network like API calls, and don't worry, we're going to talk about this in future videos, we need something more than just synchronous tasks. All right, so you're thinking to yourself, Andrei, how do we do asynchronous programming then? Well, let me remove some of this clutter. We can do asynchronous programming by doing something like this. Set timeout, which we're going to talk about, is a function that comes within our browsers, and it allows us to create a timeout. And we can just give it the first parameter is the function that we want to run, and then the second parameter is how many seconds we want to wait. So let's say I want to wait 2 seconds, so 2000 milliseconds. If I do this now, let's run into the console and see what happens. Whoa, what just happened? We have console log 1, then console log 3, and then console log 2 seconds later. It looks like we just skipped this whole step and then put this at the very end. Well, you've just witnessed asynchronous programming. In order to understand this and what just happened, I need to take you to the next part. And that is, in order for JavaScript as we know it to run, for the JavaScript engine with memory heap and call stack to run, we need more than just the JavaScript engine. We need what we call a JavaScript runtime environment. And JavaScript runtime environment is, again, part of the browser. It's included in the browsers. They have extra things. On top of the engine, they have something called web APIs, callback queue, and an event loop. And as you can see here, set timeout is part of the web API. It's not technically part of JavaScript, is it? It's what the browsers give us to use so we can do asynchronous programming. Okay, so looking at this diagram, let's see if we can figure out what our code was doing. We can create here our own call stack. We'll have web API, and then we'll have a callback queue and an event loop, just like we have in our JavaScript runtime environment. So what's happening here? Well, first we have console log that goes into the call stack, and that gets run. So we log console log to the browser. We then get set timeout into our call stack. Because we finished this first task, we're going to the second one. And with set timeout, what's going to happen is, well, the call stack is going to say, okay, I have set timeout. And because set timeout is not part of JavaScript, but part of the web API, it has this special characteristic. What's going to happen is it triggers the web API and says, hey, set timeout has just been called. And because we notified a web API, we can pop it out of the call stack. Now, the web API starts a timer here, a timer of 2 seconds. It's going to know that in 2 seconds, you have to do something. And because the call stack is empty, the JavaScript engine now goes to console log 3 and executes this. So that makes sense, right? Now we've done 1 and 3, but we still have set timeout 2 seconds in the web API. Now, after 2 seconds, when our time limit is up, the web API is going to say, okay, set timeout should be run. Let's see what's inside of it. Well, we have console log 2. So what's going to happen is it's going to say, hey, set timeout is done. We have a callback. And this callback of set timeout, we added to the callback queue, saying that, hey, we have to run something, we're ready to run it. Now, the last part, the event loop. The event loop over here checks and says, hey, is the call stack empty? And it keeps checking all the time if the stack is empty. And if the call stack is empty and there's nothing running right now on the JavaScript engine, it's going to say, hey, do we have any callbacks? It's going to check the callback queue and say, is anything in there? Because the call stack is empty, we can throw something in there and make it do some work. In our case, we say, oh yeah, I do. Let me put this into the call stack. So now we move the callback into the call stack. And then the callback, we run it. And by running it, we see that we have console log 2. So it's going to say console.log 2. It's going to run this function, and once it's done, it's going to pop it out of the call stack. And again, we're done with the callback, so we remove it. And there you go. We're done. Everything is empty, and we've just run this. 1, 3. It's going to go through the entire web API, callback queue, event loop, and then it's going to run console log 2. Whew, that was a lot of information. So you might need to watch that a few times, but hopefully that makes sense to you of why we notice this behavior. And I want to challenge your understanding here. Knowing what you know and what I just taught you, what happens if I change this to 0? That means 0 seconds. I'm going to give you a second to think about what will happen, and then we're going to try this out. I'm going to clear the console, copy and paste this, and run it. Whoa. 1, 3, and 2. Did you guess right? Now, think about why that happened. Even though this is 0 seconds, it still went through the process. It still got entered into the web APIs, and then the callback queue, and then the event loop. And by the time that was happening, the call stack had already moved on to the console log 3. And only after console log 3 was done and the call stack was empty, the event loop said, oh yeah, we can call console log 2. Hopefully that makes sense for you. And if you're able to understand that, you'll actually have a lot of people that hire for JavaScript roles ask questions like this on an interview, and you have to explain why that is. So I hope that made sense to you and you can use that to your advantage at the next interview. So let's recap. If you wanted to load your latest tweets onto a web page and you do this synchronously, then visitors to your site won't be able to do anything until those tweets are loaded. This could cause a long delay before they even get to see the content of your site. They may not be able to click anywhere and the page will feel like it's frozen. Not a very good user experience, is it? Another way to think about this is calling your teacher with a question. Synchronous way is you call the teacher, you wait on the phone until the teacher answers the phone and ask him the question. And hopefully you get an answer. So you let the phone ring until he picks up, but you're not doing anything else in the meantime. Asynchronous means you send a text to a teacher with a question. And then when the teacher, he or she has the time, will respond to you and call you with the answer. So you can do other stuff in between. So JavaScript is asynchronous when you can leave it a message. And a callback tells you, hey, Mr. Teacher has a message for you when you're not too busy. And that's why we call it a callback function and a callback queue. We're calling back to let them know that, hey, there's some stuff waiting for you. Now, we see over here that we have DOM, AJAX, and timeout. And there's a few other things. But you also see in the callback queue that we have onClick, onload, onDone. Do you remember the event listeners? Well, with an event listener, we had something like an element, and we added event listener. And in this event listener, we could say listen for a click, and it will have a function that perhaps just console.log click. Well, similar to an asynchronous way of programming, we've created this click function, and now we're just listening to it. And every time a click happens on the web page, so on the DOM, well, we run the callback function, which console logs click. All right, so to finish things off, when is asynchronous happening? It happens a lot. When you try and talk between machines, like speaking to a database, making network requests, image processing, reading files, and don't worry, we'll go through this in future videos. But to recap what we just learned, JavaScript is a single-threaded language that can be non-blocking. It has one call stack, and it does one thing at a time. In order to not block the single thread, it can be asynchronous with callback functions. And these callback functions gets run in the background through the callback queue and then the event loop to bring it back into the call stack. So next time you get asked, what is the difference between asynchronous or a synchronous program? Or how does JavaScript work? You should have a little bit more confidence to answer that question. And I hope that this was helpful. I'll see you in the next video. Bye-bye. Did you enjoy the video? I make a living creating content like this for developers. You can check out the resources I talked about in the video in the description down below. Also, I teach people how to go from zero knowledge to mastery as developers in a single course. Check out the link below for the course introduction and some free video content to see if this is something that you want. As part of the course, we have a community of people just like you, thousands of them. Hope to see you in there one day.